Air around us. Air is a mixture of gases that composes the atmosphere surrounding the Earth. These gases consist primarily of the elements nitrogen, oxygen, argon, and smaller amounts of hydrogen, carbon dioxide, water vapor, helium, neon, krypton, xenon, and others. The most important attribute of air is its life-sustaining property. Human and animal life would not be possible without oxygen in the atmosphere. In addition to providing life-sustaining properties, the various atmospheric gases can be isolated from air and used in industrial and scientific applications, ranging from steel making to the manufacture of semiconductors. The atmosphere may be divided into several layers. The atmosphere begins at sea level, and its first layer, the troposphere, extends from 8 to 16 kilometers from the Earth's surface. The air in the troposphere consists of the following proportions of gases: 78% nitrogen, 21% oxygen, 0.9% argon, 0.03% carbon dioxide, and the remaining 0.07% is a mixture of hydrogen, water, ozone, neon, helium, krypton, xenon, and other trace components. In the troposphere, the temperature as a rule decreases upward at the rate of 5.5 degrees centigrade per 1000 meters or 3 degrees Fahrenheit per 3000 feet. This is the layer in which most clouds occur. The troposphere extends up to about 16 kilometers in tropical regions, to a temperature of about minus 79 degrees centigrade or about minus 110 degrees Fahrenheit, and to about 9.7 kilometers in temperate latitudes, to a temperature of about minus 51 degrees centigrade or minus 60 degrees Fahrenheit. Above the troposphere is the stratosphere. In the lower stratosphere, the temperature is practically constant or increases slightly with altitude, especially over tropical regions. Within the ozone layer, the temperature rises more rapidly, and the temperature at the upper boundary of the stratosphere, almost 50 kilometers above sea level, is about the same as the temperature at the surface of Earth. The layer from 50 to 90 kilometers, called the mesosphere, is characterized by a marked decrease in temperature as the altitude increases. From investigations of the propagation and reflection of radio waves, it is known that beginning at an altitude of 60 kilometers, ultraviolet radiation, X-rays, and showers of electrons from the sun ionize several layers of the atmosphere, causing them to conduct electricity. These layers reflect radio waves of certain frequencies back to Earth because of the relatively high concentration of ions in the air above 60 kilometers. This layer, extending to an altitude of about 1000 kilometers, is called the ionosphere. At an altitude of about 90 kilometers, temperatures begin to rise. The layer that begins at this altitude is called the thermosphere because of the high temperatures reached in this layer, about 1200 degrees centigrade or about 2200 degrees Fahrenheit. The region beyond the thermosphere is called the exosphere, which extends to about 9600 kilometers, the outer limit of the atmosphere. Air is held to the Earth by gravity. This strong, invisible gravitational force pulls the air downward, giving air molecules weight. The weight of the air molecules exerts a force upon the Earth and everything on it. The amount of force exerted on a unit surface area, that is, a surface that is 1 unit in length and 1 unit in width, is called atmospheric pressure or air pressure. The air pressure at any level in the atmosphere can be expressed as the total weight of air above a unit surface area at that level in the atmosphere. Higher in the atmosphere, there are fewer air molecules pressing down from above. Consequently, air pressure always decreases with increasing height above the ground. Because air can be compressed, the density of the air, that is, the mass of the air molecules in a given volume, normally is greatest at the ground and decreases at higher altitudes. Barometer is an instrument for measuring atmospheric pressure. Because this force is transmitted equally in all directions through any fluid, it is most easily measured by observing the height of a column of liquid that by its weight exactly balances the weight of the atmosphere. A water barometer is far too large to be used conveniently. Liquid mercury, however, is 13.6 times as heavy as water, and the column of mercury sustained by normal atmospheric pressure is only about 760 millimeters, about 30 inches high. An ordinary mercury barometer consists of a glass tube about 840 millimeters high, closed at the upper end and open at the lower end. When the tube is filled with mercury and the open end placed in a cup full of the same liquid, the level in the tube falls to a height of about 760 millimeters above the level in the cup, leaving an almost perfect vacuum at the top of the tube. Variations in atmospheric pressure cause the liquid in the tube to rise or fall by small amounts, rarely below 737 millimeters or above 775 millimeters at sea level. When the mercury level is read with a form of graduated scale known as vernier attachment, and suitable corrections are made for altitude and latitude because of the change of gravity for temperature and because of the expansion or contraction of mercury, and for the diameter of the tube because of capillarity, and the reading of a mercury barometer is reliable to within 0.1 millimeters or 0.004 inches. A more convenient form of barometer and one that is almost as accurate is the aneroid barometer, in which atmospheric pressure bends the elastic top of a partially evacuated drum actuating a pointer. A suitable aneroid barometer is often used as an altimeter, that is, instrument measuring altitude, because pressure decreases rapidly with increasing altitude.